In this lesson we will discuss some additional features that can be of interest to better understand ML. First, we will see how to evaluate the impact of a single input variable on model predictions. Then, we will discuss the trade-off between interpretability and explainability of ML models. Finally, we will overview the idea of penalized regressions. If the model is simple, for example a linear regression, the impact of each input variable can be easily evaluated through the value of its coefficient. But, for a more complex model, none of the internal coefficients directly describes the input-output relationship. However, this input-output link can be highlighted by performing a sensitivity analysis in which one input variable varies at a time. For example, consider a reference case and get the prediction. Then, we can change the value of one variable and get the new prediction. The ratio between the variation of the prediction and that of the modified input gives the sensitivity with respect to that variable. Here you can see a practical example from a medical application. The goal of machine learning and prediction models is that of interpretability, that is, the minimization of the prediction error. They aim to interpret the data to predict in advance the next observations that will be made available with low errors. However, too complex models pay a price in terms of explainability. The more a model is complex, the less it is explicable, that is, it is difficult to trace the reason why the prediction was of a certain type in the case of too complex models. There is therefore a trade-off between interpretability and explainability. Simpler models may increase the prediction error, but are more explainable. Vice versa, very complex models can give very low prediction errors, but it is not possible to explain adequately where the prediction comes from. This trade-off can be formalized when model fitting is carried out. For example, we will now see how it can be considered through the so-called penalization in linear regression models. In penalized regressions, the goal is not only to minimize the sum of the squared errors, that is the MSE. But, there is also a second goal, which is to reduce the complexity of the model. For example, the number of input variables that are included or the magnitude of the coefficients associated with the input variables. Two widely used examples are the lasso and the ridge regression. For lasso regression, together with the minimization of the MSE, the sum of the absolute values of the coefficients in the model is minimized. For ridge regression, together with the minimization of the MSE, the sum of the squared coefficients is minimized. The result in both cases is that of making some input variables negligible through very small or even null coefficients.